Back. This is Mr. Hassan's Maths channel. I'm now going to answer question number 10, part B. This is question 10, part B from the May-June 2022 Cambridge 9709 Pure Mathematics, Paper 1, Variant 3. This question is about this function. So this is from part A. We're using the same function. It says function f is defined by f of x equals 4x plus 2 to the power of negative 2 for x values greater than negative a half. A point is moving along the curve y equals f of x in such a way that as it passes through the point A, its y coordinate is decreasing at the rate of k units per second, and its x coordinate is increasing at the rate of k units per second. Find the coordinates of A. So at the time when it's passing through the point A, okay, the gradient of the curve, if you drew a tangent here, would be such that the change in y over the change in x would be minus k over k. It's negative 1, basically. The gradient is going to be negative 1. That's what you could say. Okay, because you can say that the rate of change of y, dy dt, is going to be negative k, and the rate of change of x, dx dt, is going to be k. So we can say dy dx is dy dt times dt dx, which is going to be dy dt is minus k times dt dx is 1 over k, which is going to be negative 1. Yeah, so whatever it's like it's gonna fall by k on the change in y over the change in x. It's going to go right by k, so the gradient is going to be negative 1. So we know that dy dx, okay, at the point A, dy dx is negative k, or negative 1. Sorry, dy dx is negative 1. Okay, so that's a little explanation of that. You can think of it in terms of rise over run. You can think of it in terms of the chain rule. But in the end, the gradient of the curve at A is negative 1. So if we know that dy dx is negative 1, that means f dash of x, the gradient function, is negative 1 at A. So that means we got to differentiate this function. So to differentiate this function, f dash of x, we can use the chain rule. So we're going to multiply by the power, minus 2 times the function as it is. Take 1 from the power, so minus 2, take away 1 gives you negative 3. Then don't forget to multiply by the differential of what's inside the function, which is 4. So we end up with the gradient function, f dash of x, is equal to negative 8. And I can write this as over 4x plus 2 to the power of 3. I've just written in this form with the index underneath to make it easier for us. Now we know at A, as we just determined, at A, f dash of x is equal to negative 1. So we can now use that fact to solve this problem. So we can say minus 8 over 4x plus 2 cubed is equal to negative 1. So when we solve this, you can multiply both sides by 1, negative 1, you're going to get plus 1. So you'll end up with 8 equals 4x plus 2 all cubed, which means that 4x plus 2 is equal to the cube root of 8. So 4x plus 2 is equal to 2. The cube root of 8 is 2. So 4x is equal to 0. 2 minus 2 is 0. So x equals 0. That's the x coordinate. And the y coordinate is found by putting 0 back into the original function. Okay, so the original function is 4x plus 2 to the power of minus 2. So you have 4 times 0 plus 2 to the power of negative 2. That gives you 2 to the power of negative 2, which is a quarter. So therefore, the coordinates of A are 0 and 1 over 4. And that's the answer to 10 part B. Okay, 6 marks. But a little bit of a trick to that is that if at A, the rate of change of y with respect to t is negative k and x is positive k, then it's going to be basically a gradient of negative 1, as we confirmed by the chain rule here. dy dx is dy dt times dt dx, which is minus k times 1 over k, which is minus 1. So that's the value of dy dx. And that's how we sorted out this question. Okay, other questions from this particular paper can be found in the playlist that will appear over here at the end of this video. Other questions from the topic of differentiation can be found in the playlist over here. That's differentiation from P1 of Cambridge. And I'll also put here a playlist which is dedicated just to the related rates of change of differentiation. Find that over there. You can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.